for 118 today, we're going to be working on Module 4. This is going to be the legacy milling, and I will have all of your modules for the rest of the semester out today. So in this module, I've given you a Fusion file, a regular STL solid model file, and then I've given you a DXF file that you can import into AutoCAD or anything, and it really, it's be just kind of be a little more stripped down. So if you've already had some type of CAM class, then this program becomes really easy for you. Whether you're in Fusion or in Mastercam, you can import this directly into that program. Chance, have you had Mastercam? Okay, have you had anything in Fusion? Okay. Then we'll go through some of that stuff together. What I'm asking you to do is import this model into Fusion or into Mastercam, and then you can create this. You can create the program off of the machining operations that are here. Okay. So, but remember, we only have 2 weeks left of class, and that's really less than 2 weeks. Okay. This is a primarily mill part. You need to be working on this part while we're working on the other parts. Today, we'd like to go ahead and start putting some holes in our other part today, right? So you actually have 2 parts. 1 part to make 6 flats on, and 1 part to make 3 MPT holes in. Correct? Okay. So you're going to create a taper gauge with handle for this part. This is the part. And it is about 9 inches long. And so you'll mill all the way around it. It's got a side hole that comes through it here. This hole right here is tapered. What I want is something similar to a go, no-go gauge that has that correct taper on there, which you'll turn on the lathe. I want you to make it out of one piece. You can knurl the handle. It could be tapered, and then it could be undercut, and then have a handle on it, however you want to make it. It needs to be something usable. So it's for Jacob's class next semester to use as a tapered gauge. Okay. So here's how I would do this: is I would make sure that when the taper is correct, the bottom of the gauge fits flush at the bottom of the part. That's how I would, this is how you know it's right. You'll know that bore is too big if the gauge sticks out the bottom. You know the taper is too small if the gauge doesn't go all the way down to the bottom. See what I'm saying? So with this part, there's really not a lot there. It's just a lot of holes, is all that it is. Okay, so you're gonna have a part, and like I said, it's about 9 inches long. You're gonna mill some steps and a little curve right there. Square the outside, mill this angle. Then you've basically got holes, 4 holes that are the same, 4 holes that are the same, a slot, a through hole counterbore, another hole here, stand it up on its side, and do this last hole. Okay. I think the part is about 900 thousandths thick. I would try to take material off both sides if it were me. You can get away with just taking the material all off of one side on this part if you want to. Okay. So I think this part's going to need, you've got to do it in 2 setups, right? Like there's just no way to do it in just one singular setup because you have that one side hole. Unless you build a plate to put on the 4-axis where you can rotate it up and pop that other hole in it. See what I'm saying? So like you come out of that 3-jaw chuck, and basically you have a rotating plate, and so you mill the whole thing on the plate, rotate it up 90 degrees, drop that hole in it. Okay. So for those, I think what we'll do today, we'll focus on getting our A-axis stuff going. And then, Eden, you can do yours in Mastercam if you want to. I'll probably just help you guys through some fusion stuff to get that stuff going, okay? Because I want you to do a little bit of cam stuff in here, you know, just because it's going to be a little easier to do, really. But it's a little bit of a learning curve. What do you need other than, are you just distracting?
I'm just in here.
Okay.
I'm taking like a 300 pound out the cut, but it's like, I mean, it's slow.
Slow, yeah. Got the grinder running?
Do what?
Got the grinder running?
I don't have any more parts to grind.
Okay. Got your lathe parts done?
Do we have material for, well, I probably still need, I only have to do the screw.
Screw. Okay. Yep, screw's just mild steel. So there should be some 1 inch on that. I may have some bushings that you can put in the end of it, so you'll have some oil light bushings to run on the ends of it. Have you already got your holes done on the ends? Okay. So we can do those then.
Okay.
I gotta do these guys, and then I gotta do the Jacobs, and then I'll grab you. All right, so let's talk. So this is the next module. Okay, so Eden, this is probably the easiest part for you. So create a taper gauge with the handle, create the CNC program using either CAM, conventional, handwritten code, or a combination of both. Finally, machine the part. Submit all prints, programs, and parts. A submission box is provided. Okay? So, pretty straightforward. Let's go back to our modules for Module 3. And the first one to work with is this guy. And we already came up with, or we think that we may have come up with, a scrap part. William was sure that it wasn't his. He assured me that he only makes good parts. So if we have a scrap part to make for our first part, it must be one of your own. So all we're going to do is we're going to put this part in that 4-axis chuck, okay? And then we're going to basically mill a flat. I would actually probably do it like this. I would put it in, let me back up a little bit with the camera. I think I would probably do it like this. You're going to put your part in there like this. This would be the threaded part. And you want to leave it outside of the jaws some. So like, yeah. So something about like that. Where do you think that X0, Y0, Z0 would be on this part?
Very end.
Yeah. So X0, Y0, Z0, top of the part. Be fine. You can also do it in the middle of the part. That way it'd be the same. It's the same all the way across. I don't think it matters. So here's all that I would do. This is how this is so simple. So simple, it's just ridiculous. Face mill pass, rotate, face mill pass, rotate, face mill pass, rotate, face mill pass,
That's not how I was
rotate.
gonna do it, but that makes sense.
It was super simple.
Okay.
So your program is, okay, so we've got, like I'd probably use like a 2-inch shell mill on that. Position that 2-inch shell mill. Or you could use 3-inch shell mill and come right kind of center. And you're gonna go to height, so the flats across this are 1.3, right? So in order to get 1.3, you're gonna have to do a little bit of math to figure that out. Now, if you go to the middle of the part, touch off on the top of the part, go down 3/4 of an inch, part 0 set, then this just becomes what? 650,000 positive. I could see it on your lips, okay? That's why Z0 in the middle of the part's easier.
Okay.
So, otherwise, you need to figure out how much you need to take off the top of it.
Okay, because C0 would be at the center of your.
Center of your rotation, yeah. It doesn't make a difference. It really makes 0 difference at all, okay? So, otherwise, you're just gonna need to do some quick math to figure out from 1.5 inches, how do I make a 1.3 hex from 1.5 inch piece of stock, okay? So, it's not gonna be that hard. You can do it either way. So, all it is one face mill cut down, then you're gonna go A, and then your rotation. So,
Would you do that in degrees?
Yep, so you're gonna do it in degrees. So what's your rotation? How many degrees of rotation are you gonna need?
360 pi.
That's their side.
6 sides.
Divided by 6. So he said 360 divided by 6.
So 60 degrees.
60 degrees. So your first rotation is at 0, right?
Yeah.
Your second rotation is at 60.
Okay.
Bingo.
And you just, like in the code, it's just A.
A60,
Oh, you have to put R.
A60, A120, A180, A240. See how simple it is? It's way simpler than you
Yeah.
think. People are always like, crap, man, we're gonna go 4-axis, it's gonna be hard. I'm like, it's
Well, I wonder if that was all it was. 'Cause
Super
if
simple.
It just measures in degrees, you just enter a degree measurement.
yeah.
I just didn't know what the line would look like.
So it's just literally gonna be G0, A60. You can feed it there if you want to. I wouldn't. Okay. And then for the face mill, I'd go down, up, down, up, down, up, down, up, all the way across, because face mill doesn't matter directionally.
Not
Right.
that I would, but if you wanted to get the spindle just spinning nonstop, would you like A spindle, or an A and 3, like, well, anything like that? How do you get it just like continuously spinning at speed?
To turn, like to turn
Yeah,
apart.
Yeah.
Yeah.
If you wanted.
So
What does it max out at on those mills?
it'll do probably 4 or 5 rotations before it needs to rewind. Yeah.
Oh.
It's got cabling inside of it. You know what I
didn't
mean?
think about that. I was like, we'll
Yeah.
just spin
It's not
continuously.
actually-
It's not a lathe.
It's
Yeah.
not a
It's not a
It
lathe.
just rotates.
Yeah.
I
Yeah.
wanted to do that.
Yeah. So same thing. I think it's funny because people think the same thing on the lathes here. When you're milling something, they're like, well, how come it can't just, because it'll do like a whole bunch of rotations, and then you'll see the program stop and it'll rewind. And they're like, why can't it just run forever? I'm like, well, because that motor is not the same as the lathe motor, right? So the lathe motor just is like a big electric motor. This is a servo motor that's actually knows the degrees that it's turning, and it can only turn so many times. And then finally, it's like, whoa, I'm out of ribbon here. I need to rewind backwards. So like on the lathes out here, like the STs, they'll do probably 200 rotations before they run out of knowing where they are, and then they've got to rewind it back.
What's considered rotation?
360. Yeah.
So what if it's spinning like 2,000 RPM?
But it would never be doing that on like a whole pattern. Two different motors control.
Live tool when you're like.
Right. When it goes to live tool mode, it's a different motor that controls the rotation of the chuck. Then when you go to the lathe, you go back to just a regular, basically a belt drive motor.
Okay.
So there are two different things that's going on there. Yeah, so that's the differences in that. So that's why if you'll notice, like when I'm running parts over here and I'm milling the hogging out the inside of it, the lathe isn't spinning too, because I'm in live tool mode. So my lathe chuck isn't spinning because I'm no longer turning, I'm milling. So it's not turning and milling at the same time like that. So, all right, so now for your hole. You're going to be doing on this one, just a half 13 hole. Okay, so after you've got your flats on it, you're going to do spot drill, rotate, spot drill, rotate, spot drill, rotate, spot drill, rotate, spot drill, rotate.
Is there only 3 holes though?
It's just 3 holes.
Sorry, spot drill, rotate, spot drill, rotate, spot drill, rotate. On every other one, okay? So then you're going 120, 240, 0, 120, 240. Then you're going to run your 27/64 drill down. And if your top part, so if one of your flats is Z0 or the top of your part is Z0 or wherever it is, then it needs to go down to Z0 because they all got to meet in the middle. So, or Z minus whatever that number happens to be. And then you're going to run your tap to depth, okay? Which just taking it down as far as you can to get full thread. Now, when you move over to the other one, all right, any questions about this? This program is super simple. All right, so let's look at the other one.
Use the probe to probe Z0 once you know the flats or whatever.
Yeah, but I mean, why would you need to?
Just leave it there at the center.
Yeah, I mean, if my Z is on top,
I don't know, I just heard you say something about probe the flats, or Z0 the flats or something, so.
yeah, if you wanted to set, you can set Z0 to the flats. Let's just say this is 150 thousandths arc. Okay, the arc of that is the chord. Let's just say this part is 150 thousandths. I would make this Z0. So I would go touch the top of my part and move down 150 thousandths, part 0 set. That way I can mill to Z0, and then after my flats are there, all my Z moves are negative after that.
Oh, that would be when you're drilling?
Yeah.
Okay.
So then then this part right here is then 850 thousandths from here to here. And so then I could run my drill down to the middle at 850 thousandths or whatever, however I want to do it. You can do that one however you want. You can, if you do the center of the part at 0, you got to remember all these motions are positive. If you do this or the top of it, all the Z motions are negative. Only 2 differences between those 2 things. So that should not be an issue. All right, let's look over at your other part. So this one's real simple. You're just going to chuck it.
Will any of the other modules like require us to make a print to do what we're doing this one right now?
Other than the legacy one?
So they're back to straightforward.
Yep. Yeah, the legacy one's the only one I want you to do that on. Okay, this part, what do we need to do for it?
Just rotate it and drill it, right?
So it's going to be really similar, right? The only thing that we have to pay attention to is we're going to still do our same 3 rotations. Say X0, Y0 is one of these, Z0 is on the top or the middle, however you want to do it. You drill through it, rotate it, rotate it, rotate it. Now here's what you're going to have to do on this one is your tap, since it's tapered, has to go to a certain depth.
Oh, so it fully engages the threads,
Right. Because remember that flat or that gauge I showed you with the flat on it?
Mm-hmm.
That's how you know when it's there. You get plus or minus a thread from the flat.
So the threads don't go all the way to the center?
Threads don't go all the way down to the middle.
Okay.
So that means you're going to have to do some calculation on the tap. So there's a really easy way to do it. If you, let's say this is Z0. Thread it down 100 thousandths. Check it. If it's not right, thread it down another 100 thousandths, check it. You're like, okay, so I got 3 threads left to go. It's a, say it's 14 threads per inch. Take 14 divided by 1. You'll know what each one of those threads goes to, right? So like 20 threads per inch is 50 thousandths every revolution that it goes down. So if you can count those threads on that gauge, and you're like, I need to go 3 thousandths or 3 threads deeper, and so then you can know what each one of the threads are, and then go down 3 threads deeper. Okay, so if each one of those threads is 62 thousandths, then you need to go down 3 of those to get down to where you need to get to. See what I'm saying? Okay. Now, here's the only hiccup on this guy, is there is not a way to hold on to this. So you gotta make something to hold on to this thing with.
Shove through it.
Yeah, so what I would do is I would find myself a piece of stock about 2 inches in diameter, and I would turn a diameter. We ended up going 1.2 on the through hole, I think. Is that what we ended up doing?
Yeah, 1.2.
1.2. So turn that outside diameter of that spud to 1.2. We slide our part over it. We're gonna make it, this part is 2 inches long. We make that part, the turned part, 1 inch 900. You with me? That way it doesn't go all the way. And then we make a plate on the front of it. We tap a hole in the front of it, half 13. We put a plate on the front of it with a hole for a half 13, clearance for a half 13. And so we slide our part onto that spud, and then we put the plate on there and then screw it on, and it pinches it in. And then we'll be drilling into that spud. But then that spud works for all 3 of them, because you all need to make your bores the same. Okay. And so we've modified the print to be all 1.2 for the diameter on the hole. And so you just make them all so that they're 1.2. You make that 3 or 4 thousandths smaller. Just let it slide over it, and then it just becomes the one that you use for it all the time. All right? So like in the future, if I have other students make this, hey, here's this fixture that we already made to do this, and so.
And then you just throw the trash right in front of them. You go, okay, now you can.
Now you make one. Yeah. So, yeah. I mean, every group gets to make some tweaks, right? Like, so you guys are gonna make the taper gauge and then this fixture for it. The next group won't make those things. They'll make something different, So, just the differences in those things. But yeah, just remember these taps don't go all the way through. They tap to depth. You gotta have the gauge to get them to depth. Plus or minus 1 thread on it. So that flat could be below 1 thread or above 1 thread. The goal is nominal, to be flat even with the diameter. Same thing though, G0 860, G0 A120 for your 3, Okay, questions?
So we want to sort them first, because I was thinking I would do all the lathe stuff, so anything that has a lathe application, do that and just save 4-axis stuff for next week, instead of taking like this part, my finished part right now, and going in the mill and finishing it and turning it in. Instead, since I'm already on lathe, I can do all the lathe stuff. I start programming for the other modules right now or whatever I can for lathe.
Yeah, so go ahead and work on your taper gauge today.
Taper gauge area. Should I make that on a manual or just CNC?
I'm making on CNC, the CNC class.
Makes sense, I just didn't know.
You can make your fixture too.
And where do I get the taper measurement from? Is that on the print that he measured and used?
Yeah, so.
Yeah, that's our scrap part, test part. This is my finished product. Here's my radiuses right here. Those chamfers with the radiuses.
Oh, nice. So I'll give you the dimensions off of this part if you want them.
Yeah.
Here's the radius at the top of this hole is 418. Nope. are 250 or diameter is 500.
So then you just do some math to find out what the taper would need to be between those 2 points. Or wait,
And then the part is 950 thousandths.
oh yeah, on CNC you just list both points, you don't even need to.
You do not need to, yeah. The math is just easier for you,
I
right?
can knock this thing out easy.
Yeah. So like on that part, I would probably do something.
Just a face off and then.
It's off and then
Like
two
you said,
points.
one roughing past that.
You can go.
Finish, and then you're done.
Yeah.
You're sitting at 10 minutes. Like 30 minutes.
Yeah.
So like I'm gonna make something that goes like this. And maybe here, maybe I put a little undercut, a little groove or something, and the rest of my handle. You don't have to, though.
That's what I was thinking.
I mean, so make this 950 long. And then, you've got your diameter here, your diameter here. And, I mean,
Have you want it knurled? Have we done it on CNC?
no, but I've got a really sweet knurling tool that if I can find it quick enough that you can use to do that. You could put some little grooves across the top of it or outside of it or something.
Put my name in it.
I don't know that you could do that. But you could put a couple grooves around the outside of it. You could leave it straight turned. You could knurl it. You do whatever you want. A really nice spring-loaded knurling tool that works really good with that.
What's the knurling code? You just use G71 without it?
You're just going to use G1. So,
Oh, just run it
yes,
across the
let's
feet.
just say you turned it down to
Where-
inch and a quarter diameter.
The manual, we just kind of pressed it in, so it felt right.
Yeah.
Is there like a specific, like?
Yeah, so I just go about 10 thousandths deep on it.
10,000, okay.
And so it's got a top and bottom roller, spring-loaded. And
Where should you start that, like off the end of the part, go 10,000 deep and run it across?
yeah, you can. You can start on one like that, only going 10 thousandths deep. You can start off the edge and go across it. What I normally do is I come up to kind of the, just like I would a normal knurling tool, I go ahead and just bring it right down on the diameter of it and then feed across it.
Okay.
So I don't go
Spin
this
that.
way with it. I go into it and then feed across it. I'm probably going about 150. And then just flood cool and all that on. Yeah, don't have to use oil or anything. It's really slick though. So that'll be it for that. So if you want to do all your turning, then you're our spud guy and you start on your own gauge. Everybody's got to make their own gauge. I only need one fixture, right? So somebody might make the cap and somebody might make the body. And then
Sawed off piece of material.
exactly, it does not need to be fancy at all. Yeah. Just put a 1/2 inch hole in it and that'll take care of it.
When you run the nose crush, you run back at all?
I don't think I would. I don't think you'll need to.
It'll look fine.
Yeah. It's remarkably smooth and accurate on it.
What did you go for now? Like 12?
10 to 12.
10 to 12.
So go across that and then maybe chamfer the front and the back side of it, part it off, done. So everybody should be slightly different though, right? So they shouldn't all be identical in the way that they look. They should have
What are you trying to do?
all three of your gauges. Should look slightly different. I mean, the angles on them, but use your own, put your own style to making the part how you want it. I mean, you can knurl the handle, you can put grooves in the handle, you can knurl the handle and put grooves in the handle. I don't care. And so some people may have the groove behind it, some people may not. I don't really care. So it's got to be enough that it can get all the way down. So you can't go like 950 and then you can't go up higher there because it won't. It'll only measure the gauge if it's like perfectly right. So you got to go up from there, and then you got to give yourself the ability to work to be gauge worthy, right? So that finish will need to be nice and smooth and slick across there too. But you can make it out of aluminum; it'll be fine. It'll look good. All right, so that's what. If you're just working on lathe stuff right now, then that would be the thing to do. If you haven't got your part made, then you need to get your part made. If you're ready to get started on the legacy part itself, or if you want to go ahead and start on the 4-axis stuff, Brian might be over there on that machine. You could probably talk him, he's probably not far enough that you could probably talk him into moving somewhere else, but.
You said 1 4-axis machine?
We do, yeah, we only have one 4-axis rotary.
Is it 5? Oh, okay.
Yeah, so the 5 can do it too, but it doesn't have a chuck on it right now.
Got it.
So you really need to kind of put a chuck on it and then flip it over, and then you can do it. It's probably easiest, since there's only 3 of you, to just call out tomorrow, hey, we need this machine for these guys, you know? But you can't not run it, you know what I mean? Total butt move to be like, hey, we need this machine tomorrow. And then no one runs it, and you're like, yeah, we actually didn't get to it. I got deep in Minecraft and just did not get anything done. So, you know.
I got one in my